In the previous video, we saw that if people do what's best for them, society wins. And that's the normal situation. This is the fundament that our profession is built on. Individual rationality, after all, leads to socially superior outcomes. However, there are social interactions which may lead to inferior outcomes for the entire society, even if individual decision makers act perfectly rationally. So the purpose of this video is to present the basics of exactly those types of interactions. So consider the game, exactly the same game that we've had before, with slightly changed payoffs. Rather than payoffs of 1 and 3 in the upper left cell and 3 and 1 in the lower right cell, we have now introduced a minor change in the payoffs. The payoffs may change due to a variety of circumstances, such as prices, consumer preferences, climate change, in general, anything relevant to either the benefits or the costs of the two players. Now, the question we want to ask here is, and economists typically ask, is the following. Is there a dominant strategy equilibrium? Let's see. Notice that Anil's payoffs given what Bala can do. If Bala plays rice, Anil has two options, play rice or play cassava. If Anil plays rice, however, he gets nothing, right? While if he plays cassava, he gets he gets 4, right? So Bala plays rice. Anil can choose rice or cassava. If he chooses rice, he gets 0. If he chooses cassava, Anil gets 4, right? So it's a no-brainer. If Bala plays rice, Anil needs to play cassava if he's rational. However, what if Bala plays cassava? Anil has two options again, play rice and get 2, or play cassava and get 1. It's clearly rational for Anil to play rice. However, this means Anil no longer has a dominant strategy. There's no strategy that he plays, no matter what the other player does. There's no such strategy which yields the highest payoff for him, no matter what the other guy does. So that's why he doesn't have a dominant strategy. And similar things happen for Bala. If Anil plays rice, it's optimal for Bala to play cassava. But if Anil plays cassava, then Bala can choose to have a payoff of 1 or 4. Well, no rational individual will choose a payoff of 1 when they can achieve 4. And therefore, Bala chooses 4. But hold on. Then we have a situation in which Anil playing cassava leads to Bala playing rice, which is what we've had before. However, if Anil plays rice, it's best for Bala to play cassava. So we don't have a dominant strategy equilibrium in this game because we don't have a dominant strategy for either player to begin with. That's why we have a different equilibrium in this game. An equilibrium in which everyone plays their best response given what's best for others. This is what we call a Nash equilibrium. Notice that we introduced a small change in the payoffs of the players in the invisible hand game. Before, when we've had a dominant strategy equilibrium, when everyone was playing their best strategy irrespective of what's best for others, then society was getting the most out of the social interaction. But now, when we have two possible equilibria. Yeah, they're possible because the best strategies of each player do depend on what's best for the other players, right? So when each of the players plays their best response given the strategies of others, we arrive at a situation called a Nash equilibrium. However, notice that this may lead to the old equilibrium of 4 and 4, right? But it may also lead to an equilibrium with far lower societal benefits. As a whole, society gets twice as much when everyone plays their dominant strategy, and twice as little when it gets into a bad Nash equilibrium. So as a result, the economy may get stuck, unfortunately, in a bad equilibrium. People are still rational, they do what's best for them, but unfortunately, the overall result they get is far from ideal, far from the optimal from both individual and societal standpoint. In this week's seminars, we will show how we can solve this societal problem. It turns out that coordination between players may, in a way, unlock the potential of the economy to generate good outcomes for both its economic agents and society as a whole. So keep coming to those seminars. In the next video, we'll revisit one of the most famous games, the prisoner's dilemma game. It will illustrate another example of suboptimal social outcomes when individual players play their dominant strategies. Thanks for watching.